I'm CK. Today we've got another one from Befaco. It's not a module to go in your rack, it's their Chikipower, a little benchtop power supply to provide power to 1 or 2 modules when you're debugging, testing, or after you've built a module. Very optimized for use on a desk, on a workbench, so it's got a stand, it's got the right things. It apparently can do, let me read this, up to 400 milliamps per rail with a 20-watt USB charger. So you'll need a good-sized USB charger, but this will be perfect if you only build an occasional module and you don't build up a workbench test box like I did. So we'll put it together, see how it works, and I hope you enjoy the video. Here's the bag, picked it up from thonk.co.uk as usual. Please follow the assembly guide carefully during the thing. One thing that's going to be of value to you is, because it does have this little, as you can see in this bag, let me pull it out, it does have a top and a bottom with a little heat ventilation, which is nice. That looks like a switch, and that's probably LEDs poking through there. Oh yeah, switch, and plus 12, it's telling you the voltages on various rails, and red, red, red. Maybe it has multiple, oh it does have multiple, it has 3 outputs. Wow, that's interesting. That's pretty powerful. But this will keep the thing from grounding out on your workbench. If you just built a regular a regular eurorack power supply, and you set it down and you had a piece of solder lying around, you might short out some contacts. This will prevent that. Connect only to high power or charging USB ports. So again, be careful with this. It will put out 4.5 watts for USB 3, 7.5 for USB BC, USB Type-C 1.2, 15 watts USB chargers, up to 20 watts. And what do we have here on the board? We already have, let's see, let me get my pointy thing. We've got I think that's probably a 10 ohm fusible resistor. It also says PPTC, so power protection thermocouple. I'll call it a thermocouple. Then we've got a MLV1. I don't know what that is. Might be a diode. A couple of resistors here, the USB-C connector, and then another diode over here, a big diode over here. Some resistors here, LEDs, which will show you, as I showed on the other side, it'll show you what the 12 volt, plus 12, minus 12, and plus 5 voltage is operational. A little edge connector for some reason or other. Then we'll put 3 connectors on, 16-pin connectors on. And then we've got shell ground. So I don't know whether that can, yeah, that's a splittable. I'm not sure why. So these 2 pads are connected with a little solder bridge, and we'll find out why. Let's look in here. It doesn't look like it's too, Befaco sticker, got that one already. It doesn't look like it's too complicated to build, in fact. In fact, it may be trivially easy to build. Here are the 3 connectors to connect up to 3 modules, and here is the big brick. Meanwhile, GKM10E Echo -12. Voltage in, DC 4.9 to 9 volts, so USB power at 4.5 to 5 volts is fine. Output is DC plus minus 12 volts at 416 milliamps. Then we've got labeling the pins, voltage out minus, voltage out plus, common, voltage in negative, and RC. Reference current? Maybe. And that pin's a little bent. I'll have to straighten that out. That's straightened out pretty well. We've got a switch. It's a good switch. Got some red LEDs. Let's put them on the LED buddy just to make sure they're red. Now, where did I put it? There it is. I mean, to make sure they're red. No, I just want to play with the LED buddy because I like it. There it is. 1.8 volts. Takes a 560 ohm inrush or current limiting resistor. But that's probably incorporated in here. Actually, it might not be. I'm sorry. That's what these resistors are. These resistors are going to be the current limiters for those LEDs. Let me see if I can have any chance at reading the values on here. $2,201. So 2.2K? That seems high, but they know what they're doing. So it looks pretty straightforward. We've got little attractive spacers and standoffs and things that Befaco likes to add because Befaco makes attractive stuff. And little hex head screws, which comes with a hex head wrench. So, oh, what else is in the bag? I'm sorry. Let's get the other thing in the bag out. And this will have to cut open because I'm incapable of doing it like a competent human being. It's a USB-A to USB-C, so that's good if you need that. So everything you need to have a little power supply on your desktop or workbench for testing one or two modules together. Very handy. So I'll get the soldering iron heated up and we will put this thing together. I brought the build guide up from Befaco's website and I'm going to do a quick glance through it. This is pretty, oh, it's got more pictures than Befaco usually has. And they're good pictures. Shows you how to assemble it, shows you how to check that it's making, that you've done the right thing, because you can obviously check the voltages at the appropriate places on the appropriate output pins. So first thing we're going to do is we're going to separate the circuit board from the sprue and sprue so we can work on it. Some people like to keep things together. I don't. Now, of course, since we just broke the pieces out of off their sprues, there's little rough edges there, and that's not what I want on my desktop power supply. So I'll get my little piece of sandpaper, very fine sandpaper, rub the edges on it. You don't have to do that, or this. I like to, just because I don't want rough edges on things I'm picking up and moving around. All good. So first thing we're going to do, get our soldering pad back in position, and we're going to put the three, oops, I still have some or sanding dust on there. Put the three power connectors on. You can't really get this wrong. But because I am the paranoid person that I am, I'm going to set this the way it goes and take a power connector and check the keying. That must be backwards. I'm backwards. So that's going to be on top. And as you can see, the red stripe is where it's supposed to go. So that will be all good, and we want to flip this over. They recommend using one of the other circuit boards to do so. I think that's a fine idea. Even though, why isn't this going... Oh, look at that. This diode is very close, so you may have to manipulate it a little bit. See, I just keep messing it up. The diode is right up against this connector. In fact, I don't have it right. Come on, diode. You're in the way. I'm going to have to send them a note about that. That's no good. Let me write myself a note to write them a note. I'll send that when I get done doing this, because that's no good, and theoretically someone who's not as experienced could bounce that diode off the board, which would make you very sad. Okay, so now everything's flat and reasonable. So what I'm going to do is I'm going to do one pin on each of these. Now I'm going to pick it up, take a look, make sure they're all flat to the board. That's not quite flat. So I will reheat that one. Push down on, oh, that's the D1. Oh, no, that should be flat. I guess there's a little space. I guess there may be a little, and there's a little plastic piece holding it up. Okay, not a big deal. Just wasn't expecting, oops, that. Okay, now I'm going to solder all these pins. Oops. That pin didn't go in right. Oh, it's on the D2 one, that's why. The pin didn't go in right because I had to force things a little bit, so get it in there. So I'm going to take this back apart. Doesn't really matter technically, because both pins lead the same way. You can see that's really bent down. But again, it was because I had to kind of force past the diode. Let's see what I can do here. So let me show you what I did. On this connector, first I straightened out the pin with a pair of needle nose pliers, and then I tried it again and I was still interfering, and I was worried that I was going to, I have a little bit of sprue in here. I was worried that I was going to bend it again, so I actually took my rotary tool, my Dremel tool, and I cut off this part of the shell. Doesn't matter, it's not going to affect the fitment or electrical side of things, but now when I put the connector back on, hopefully you can see here, let me see if I can get focused. You can see I've cut away the plastic that was interfering with that diode, and I have all my pins through. So that's good. So now I'll go back to soldering that. And there's that. Let's see what the build guide says next. I'm checking just to say, yeah, it doesn't say anything about that in the build guide. Now we'll take the brick out and put that in there, and if you'll notice, the pins are offset, so these three are equally spaced and these three are not. So there's only one, and the holes on the circuit board correspond to that pattern. So it would be difficult to put this in wrong. I mean, not impossible. I taught airplane mechanics in the Air Force 40, almost 50 years ago now. And I can tell you, an inexperienced person can cause a lot of havoc that you didn't think they could. Again, this is the pin that was bent, so I'm working it into position. There we go. Now we'll solder those pins, and I'm going to use my thicker solder for this, my guitar amp solder, because I want lots of connectivity on these and lots of stability. And I'm lingering on it a little longer than usual because I want the solder to weep down into the plated hole to give a real good connection. That's all that. Now we're going to put the spacers on. Okay. Well, that's interesting. Oh, well, that's kind of funny. I wonder why he wants us to do that. Okay. We're going to put the spacers on first, but then we're going to take them back off because we got to put the bottom plate on later. But I guess that's fine. I'm not going to argue with them. I'll just go ahead and do it, because if you're following along with the instructions with me, I don't want to get out of sync with you. But just remember, we're doing this temporarily, primarily, I believe, to make sure we get the positioning of the switches and the LEDs right. But again, I'm not tightening these screws right now because I know I'm going to be taking them back out. And there are different size screws, by the way, they're longs and shorts, I believe. I don't know. I'll look again in a second or two. Okay, so we're going to do that. Now we're going to put the switch in its place, but we're not going to solder it yet. Now we'll put the LEDs in, and the LED positionings have good, clear, positive indicators telling you where the long lead goes. As you can see, this is going to be a pretty quick kit. Now we're going to take the front panel and put that on. And I am going to screw these down. Not super tight, but tight enough that things don't slop around. It's interesting. I've got two long screws going into the same one. I must have put a small screw somewhere. I put a small screw in where a big screw needed to go. Now, I'm not going to put those screws back in right this second because I don't need to. So we want to make sure, wow, that's quite a gap. Because you want to make sure you can throw the switch, but you also want to make sure you have enough conductivity there. And they could have made these spacers probably 2 millimeters shallower or shorter, and it would have been better. But but I think I can get good conductivity there. Put this over the side so I don't bang into it or bang it against the solder pad. And I'm going to fill these holes all up with solder. I'm going to send them a note on this too, because they should be able to fix that pretty easily. Just have the spacers be 2 millimeters shorter, and you still got plenty of clearance for everything else. I'm double checking this. Switch works. Feels stable. I'm looking to see how much of the solder weeped through, and I've got good weeping. Now we'll get the LEDs through their holes. Take a look, and they all look good. I'm going to do the same thing, kind of hang it over the edge so I don't push them back in inadvertently. So I've done one leg of each, and I'll take another look to make sure they're all there, and they all are there. So I can do the other 2 legs. I mean, the other leg. I'm going to trim the leads, and I'm also going to be trimming the leads here, I think, because I think the spacer won't cover the height of those. So let me get my other, where are my other, there they are. My beefier, I'm not going to use my flush cutters on here, I'm going to use my beefier pliers. There's that bit done. So all the LED switches on. Check my time on my cameras. Got 16 minutes of recording left on the cameras. So the next thing I'm going to be doing is putting the bottom spacer on. Actually, we're making a sandwich. So let's double check that that's right. So we're going to put that screw through there, and then put that in there. It's going to be I'm not going to do that way. I'm sorry, I'm being an idiot. I got to take these other 2 screws up before I do that. Now, and again, you may have a different technique than I do for this. This is the way I generally do things that have spacer sandwiches. I'll just put the first one on very loosely, just enough so it indexes right, and then get the next spacer and screw. And now we've got it all put together. Again, very, very quick. Here's the front. Here's the side, another side, another side, another side, and the back. Now we're ready to actually plug it in. Where's a good USB connector? Here's a good USB connector. USB-C. Going to make sure it's off. I'm going to plug it in. No, we do not have a module connected to it yet, for good reason. We're going to power it up. I'm getting plus 5 volts, and the 12s are flickering. I do not know why the 12s are flickering. So what I'm going to do is I'm going to check to see what voltages I'm getting there. Because the 5 is showing very brightly, as you can see, but the 12 is not. It's because I'm not getting 12 volts there. Got the 5. But we're not getting the 12s. Why? And that 12 volt, maybe this power supply is not this power supply is probably not beefy enough. hold on, I'm turning the cameras off because I got to go get a beefier power supply for this. And again, they do caution you against that. You have to get a good, beefy power supply. This is a 65 watt power supply, so it should light everything up. And it's not. The 12 volt keeps flickering, but it's not working. Huh. So you can see it flick on and then go off. It's if it's overloaded or something. Are we? We're not grounded to anything. Let me pull this board back apart. I'm going to pull the power cable out because I'm not that silly. I'm looking to see if anything's grounded or shorted, and it is not. I'm going to plug this in, and again, use your own judgment when you do this. I'm used to shocking myself. Just set that down, and we've got an output measuring there. So let's turn this on. Oh, wow, interesting. With the top off, all the lights are on. Huh. Well, what does that mean? Let's put this back on and see if with that we're fine too. It's with the bottom on. Let me see if I can see any marks. So something about the bottom piece is grounding out. I'm going to take some pins down a little bit more. I shouldn't need to. Trim things down again. I'm going to put 2 screws and their respective spacers on at opposite corners, and I'm not going to do it tightly yet. I'm just going to do it loosely and see if I can replicate the issue. Okay, that's on very loosely right now. I'm going to plug this back in. Power on. And we've got all the lights. Let me push this firmly. Okay, I don't know what the difference is, but it's working right now. And my camera battery's about to run out. That's pretty crazy. So let me put the others, let me turn it back off. Put the other spacers back in. Okay, I'm going to turn it on with the other spacers back in, just in case there's something. No, that's all looking good again. Okay. Alright, those are tight again, and we'll see if it lights up correctly again, and it does. Okay, I don't know what that glitch was. It's very interesting. But what I'm going to do now, as you can see, I'm going to probe around a little bit and make sure we're getting our 12 volt negative. Oops, I have my leads backward, doesn't matter, but 11.92 negative, that's fine. And over here there should be 12. No, that's the 5. That should be 12. 11.92 on that one. Go to the other. That should be negative 12. 11.92 again. Okay, that's good. Now we'll go over here. That's good. Should be 5. That's 5, and that should be negative 12. Yep. All works well. So I don't know what caused that issue. I'm never going to figure it out. Let me do one more thing just for fun, because I can. we'll plug in power connector and a cable, and let me grab some random module. I'm looking for one that's got LEDs on it because you won't be able to see anything. Okay, we'll try this little modulator, which I did a while ago. It's on the channel somewhere, I'm sure. And we plug it in, and there you go. It works. It pulses like it's supposed to. This is from Erica Synths. So, it all works well. Let me do one other thing, because throughout my career of working with electricity, I'm going to give it a sniff test. Nope, I don't smell any burning, insulation, or anything like that. So there you go. It's a little desktop power supply for your for your eurorack testing. If you have built it on your desktop and you want to power it up just to make sure it works without having to get it into your main rig where you might blow your master power supply. And it works just dandy. Another nice one from Befaco with two little nitpicks, that connector hitting the diode and these probably needing to be about a millimeter lower for that switch to be positioned better. But other than that, it's a fine unit. And I hope you enjoyed the video.